Hello, good afternoon and good morning to everybody. My name is Mohamed Ashraf. I work as a senior architect in MSys Technologies, Chennai. Today I'm going to talk about zero trust security and air gapping for secure long-term data archival. And the agenda of my talk, news of cyber extortion and malware, ransomware attacks, petya and non-petya, data archival, zero trust security, air gapping, and the combination of zero trust security and air gapping, and then general summary. We are living in a data age of cloud, age of IoT, age of connected digital world, where everything is connected to everything else. Data is doubling every year, right? It can be structured data, it can be unstructured data, but unstructured data is growing much faster rate. So along with the demand of data, the growth of data, demand for data storage, backup and archival, all these are also increasing. And cyber criminals, right? They're also finding new ways of attacking, because in the connected ecosystem, it is easy to get in, right? So you might have seen the news, news of ransomware attacks, right? And the vaccine manufacturers, drug manufacturers, Novartis, AstraZeneca, Pfizer, BioNTech, Moderna, all these were hit, by ransomware attack during this last, couple of years. And the Taiwan Semiconductor Manufacturing Company was hit by ransomware attack, and they shut down their part of their operations for many days. And the not petya kind of malwares, they are most devastating ones. They attacked some Ukrainian financial institutions initially, and they came as a software update to some of the Windows operating system and things like that, right? And then dark side attack, right? Colonial Pipeline, which is one of the nation's largest fuel supplier and manufacturer, they got hit, and they shut down the entire plant for many days. There was a panic all over, right? People were queuing near the for gas, for fuel, right? The kind of attack what they're doing is, earlier they were stealing, the credit card information or savings bank account, and then, take money out of it. But now the tactics have changed. They're actually, threatening you. They are stealing your data or encrypting your data and threatening you, hijacking the data and threatening you. If you don't pay the amount what they are demanding, they will spoil your data, right? You may not be able to get the decrypted key or whatever to get in. And so this is quite dangerous, right? So, what's a malware, right? Malware, you all know that, it's a malicious software, and, it can come through a file. It can be, intentionally, it can make harmful to your computer network or server, right? And then how does the malware infect a computer or a network, right? So, usually there are a number of methods, they deploy the malware into the system, right? And then predominantly they use social engineering technique, right? Phishing and smishing, right? And so, and most of the malware attacks are actually coming via email attachment, right? And then different malware types, virus, keyloggers, worms, and then things like that, right? And then attacks are happening to targeting most of the verticals, right? And predominantly healthcare and public health, financial services, information technology, critical manufacturing, government facilities, commercial, etc. And this is a statistics, from 2021. Okay, so now some of the malwares, we have Petya, non-Petya. These are some of the malwares, and they actually kind of ransomware. They target Windows and laptops and other things. Normally, they come via software updates or patches, right? And or email attachments, right? So this is the way they spread it to everybody else. And then what is the remedy, right? We have to do a complete backup of the system, and the system machine get infected with the Petya virus. The data cannot be recovered anymore, right? So you have to back up the data, restore the data, in order to recover the system, right? So it can be in the cloud or it can be a third-party location, right? Wherever you taken the backup, you restore it from there, right? And similarly, they are infected through vendor updates, email attachments, right? And so usually this NotPetya infected through malicious update of Ukrainian financial software. And then there are different states. The virus can go in these 4 different stages: prepare, enter, traverse, and execute, right? And what happened is NotPetya, they actually corrupt the master boot record, and the system become unbootable, right? And then also it clears the event log so that nobody knows what are the steps this malware has taken in order to corrupt the boot record, right? So and this was found in some of the Windows updates, right, during 2017, and it is one of the most devastating attack, right? And if you see the statistics, there's 600% increase in the malicious email, and then wrong attachment, and then people are actually systems are getting infected. During the time of COVID-19, it was much more because a lot of people were online, and people cannot get out. So they were targeting all these people who are online, their systems, right? And they demand money, right? They encrypt their system, and then demand for a ransom, and then if you don't pay the money, they will delete your data, or they will not give you the key, so the system become unusable. And the 35% of encrypted data not recovered after the ransom is paid also, right? And then 67 attacks in 2007, that 2021, it cost almost $3.5 billion in total, right? And then anti-ransomware softwares are there, but they are not enough, right? You have to have a secure offline data archives, and then so many other list of defense, right? Paying ransom is no guarantee of getting data back. Okay, so now less than perfect software, right? The patching routines, outdated operating systems, insufficient segmentation, all these are causing the NotPetya attack. And routine maintenance need to be done, real-time monitoring, and point security. Back up your data in multiple locations. Educate your team, and don't open any attachments from unknown places, right? So these are some of the prevention tactics. Okay, and then vulnerability assessment. You can have vulnerability identification, result analysis, risk assessment, remediation, and implementation, right? And so vulnerability assessment or scan can efficiently identify the vectors, possible vectors, and help to close them down, right? Or you can have security hardening in your VM or whatever system you're using, right? And then what's the most common target of ransomware attack, right? These are server infrastructure and the storage, network storage, right? So those are the first target, and then backup storage as well. So what do you mean by data archival? Everybody knows, right? it is actually the unnecessary information we have to remove and then from the system and then move them to long-term storage. This is called data archive, right? Backup means it will store the critical information, and archival means they will not so critical or long-term data, they can keep it in archival storage. And it is built using cold storage tiers because it is cheaper, and then it can hold a large amount of data. And similarly, it should have indexing and searching capabilities so that they are easily accessible. And then for compliance reasons, or if there is an attack, if you want to have digital forensic on the data, that time you look into data or the archive data, right? And the best practices, you have to identify and sort the data before archiving, synchronize the data, and then data lifecycle management, plan for regulatory compliance, and then use the right archiving to develop a archive policy, right? So some of the archiving technique in AWS as an example, if you want to move the data from database to AWS Glacier or S3, like some cheaper storage, or you can do from on-premise, all this log data, system logs, database logs, archive file, all this can be moved to S3 or Glacier, right? Like in picture number 2. And in picture 3, we can have like a data center. You can move all the critical information to AWS storage, right? So why data archival, right? Mainly for the regulatory and compliance purpose, right? Because there are a lot of standards across the globe, right? HIPAA, PCI DSS, GDPR, sorry, ISO 27001, SOX, FISMA, and GLBA, right? So in order to do the regulatory and compliance, they are doing we are doing the archival, right? And then we already talked about the unstructured nature of the data, right? We have around 75 to 90% of the data are unstructured. And then, 50% of the data, is inactive after 6 months. And then they require capabilities for archive management, right? And the cost of maintaining unstructured data is also high. And then you can maintain backup, recovery, space, power, etc., right? So the, data, if you archive first, right, or if you archive better way, you can spend less on backup, right? You don't have to spend too much money on backup, right? So first you migrate the static content to an enterprise archive, and so that can significantly reduce the backup workload. Similarly, file servers typically employ weekly, full backup strategy. And similarly, archiving basically negates the need to do the monthly backup or regularly making copies, right? So you don't have to retain the monthly or regular copies. Less data to backup, right? If you do archive better, you have less data to backup and less data to recover. And similarly, the retention requirements in industries are, of the order of 40 years, 50 years, right? And then the archive data after some time, the DBMS system or things will become outdated, right? It can outlive. And similarly, archive can outlive, people who designed or manage the operation systems. Archive will outlive media, we store it on it, right? So, now, okay, what is zero trust security? Zero trust means trust no one, both inside or outside the organization, right, of the network. Use visibility, analytics, and automation to keep policies in check, right? So we have multiple components: data, users, devices, network traffic, applications. So each layer will not trust or are independent of each other. So it's like extremely vigilant security guard, right? Verifying your identity over and over again, right? Every user on a network is always assumed to be hostile. External and internal threat exist in the network all times. Network locality is not sufficient for deciding trust in a network. Every device user network flow is authenticated and authorized to be authenticated, right? Policies must be dynamic and calculated from as many sources of data possible, and principles of least privilege. And the pros and cons of zero trust: less vulnerability, strong policy for user identification and access, smart segmentation of data, increased data protection, good security orchestration, right? And the cons are the time and effort to set it up, and increased management of varied users, more devices to manage, more complicated application management, etc. Now, in zero trust architecture, right, we have to worry about the user and the password, multi-factor authentication, and device, right? It should have UEFI secure boot, encrypted storage, it should have trusted computing, client certificate, and TLS at transport, right? And the application, we have to segment it from non-participating bits. Use manual TLS or SPI FFP between the participating pieces. And data can be, checksum or tamper-proof audit logs. Now, what is logical air gapping? As the picture shows, right, air-gapped networks are completely isolated from the internet or external world, right? So, it is ideally suited for backup, which can prevent the ransomware defense. Because the new ransomware attacks are actually targeting the backups, because they know that, once you, encrypt the system and then, take the key, when you demand the money, people are actually going and, taking, their backup and restoring the data. So now the attacks are coming, and first they are, spoiling the backup, right? And then they go and attack, so nobody can recover the data. So this type of air gaps can prevent, such attacks on the backup, basically. And then the air gap can be logical as well, where you can have logical process to protect the data, right? So one example of a supply chain attack, right, which happened in Iran's nuclear power plant using a STUXNET worm, right? Actually, in fact, it came through like a software upgrade of their Siemens programmable logic controllers, which they use, in the SCADA systems and the distributed control system inside the nuclear power plant, right? And so they infected the SCADA and then Windows operating system, all other things which are inside, and then slowly taken control of that DCS. And then, it started controlling the temperature, and then, slowly spoiled most of their centrifugal systems and other things which are used for the nuclear bomb, right? So they might have gone different states, right? They might have watched for 30 or almost 30 days, as you see in the state 0. And then after a steady state, they record the malware record the snapshots, and then they attack the centrifugal valves, and then secondary pressure reading, right? And then wait for the pressure change for 2 hours and attack the auxiliary valve. So, and then wait for 6 minutes and then finish. So, a series of states, the attack vector might have gone, right? So, air gaps serve two fundamental purposes, security use cases. First one is it to defend against the intrusion into the network system, protect digital assets from being destroyed, accessed or manipulated. And the challenges are, it's not easy to set up and sustain air gaps, right? And human errors, people, you need to be, the employees need to be highly trustworthy, right? If they, somebody is copying the data using a, USB device, and they know the location of the system, location of the backup where they are stored, right? So they can go and, or if they keep the USB ports open, right? All these are dangerous situations, right? And in social engineering, right? Insider attacks. All this can also get past air gaps. Network discovery also can, there's possibility that initially, when they do network discovery software, there's a possibility you can find it. Okay, so now we have to use encryption, right? So that even if the data is lost or taken, they cannot use it, right? Along with the air gap. And in here, I wanted to explain about the zero trust plus air gap, right, for the long-term archival. So in this particular case, we have to have zero trust security, right? We should have 3-2-1 air gap backup rule where there will be 3 different kinds of backups, 3 backups, 2 of them in 2 different medias, and 1 of them is physically away. So that is the 3-2-1 rule, right? So you need to have some sort of rule like that. And zero trust means you are not trusting anyone, right? Not even employees of the company, and give very limited rights, right? The minimum rights required to work, right? Required for their day-to-day work. And then all the monitoring should happen. Their network, should monitor any new data is coming from the removable media or transient devices or external network connection, right? So, the content change tracking or intelligent archival, right, which is also to be done along with the, as part of the zero trust security, right? So, and in case if they wanted to transfer data from the air gap network to the other, they can use a proxy server and a air gap server, and then can have intelligent or internal routing, right? And then all internet connection on the right is, secured through a firewall. So that internet, data cannot get into the DMZs, right? So we have the, demilitarized zone, so no attack vectors can come inside, right? So, and then for the backup, they're again keeping it in another boundary, right? Another segment. So use the combination of zero trust security and logical air gap in order to better protect, you from the ransomware attack. So once you have the backup, even if attack vector, WannaCry or Petya or non-Petya, any of these attacks happen, and they demand for sending you millions of dollars through Bitcoin, you have the data in hand, right? You have a secured long archive data somewhere that you can restore easily without paying them the money, right? Even if you pay the money, there is no guarantee that you will get the key back or the data back, right? So, and then all the users, device, application data, everything is moving these days, right? So they are outside of the enterprise perimeter and the zone of control, right, away from the traditional data centers. And the new business requirements also driven by digital transformation. A lot of risk, right? Day by day, they're exposing to more and more risk. And we cannot just do trust but verify, right? We have to have, because the threats, advanced threats, are moving inside the corporate perimeter as well, right? So you should have even the traditional perimeters, right? They are complex, increase the risk, and there are no other compatible. They are not compatible with the traditional perimeter. They are not compatible with today's business models, right? And zero trust security, you have to do by ensuring the application work quickly and seamlessly. So the best way, the secure archival, and then encryption, right, for a viable air gap. And a physical separation may not be required here, but it can be logical. But the zero trust security is a must, right? And that is a bigger player for the cyber defense. So with this message, I have concluded my short talk. And if you have any questions, you can ask me. And just one quick slide about my company. And we are from MSys Technologies, and it is a 1,500 plus employee organization. We work for ODC team building experts with the data center experience, storage, virtualization, cloud, AI, ML, things like that. And then we have tie up with the top storage vendors, and then we do professional services for the enterprises. Okay, so and we can rate my session, and then please take a moment to rate the session and give the feedback. Right. With this, I'm concluding my talk. Thank you all.